Hello all. Let us now discuss about KNN algorithm in Python. So first of all, we need to understand about the theory behind KNN. So you can watch out my video KNN from scratch. So just it will take 10 minutes to complete the video. So please have a look at it and then you can look into this video. So what is KNN? KNN means K nearest neighbors. K nearest neighbors. So when can I use this KNN algorithm? KNN algorithm can be helpful to solve both regression and classification problem. So when I say regression, whether the dependent variable is numerical, we can use KNN regressor. If the dependent variable is categorical, then we can use KNN classifier. So I have taken a data set of breast cancer. You can see, right? So the breast cancer data set I have taken, it is basically to diagnose whether the cancer is malignant or benign. Malignant or benign. Okay. So let us now proceed with that. So the step number 1, we have to import the packages. So I'm importing NumPy, Pandas, Matplotlib, Seaborn, right? Then we need to split the data into train and test. So from scalar.model underscore selection, I have imported train underscore test underscore split. And then I'm using KNearest classifier because for this particular data set, the dependent variable is categorical. So I'm using KNearest classifier algorithm here. And then from scipy.stats import z-score. So whenever we work with the KNN, it is better to do standardization or normalization. Most probably we will go ahead with the standardization. So I have just taken import z-score, right? So I will just make a model with the standardization. Once you write down the code for this video, you need to try without standardization, right? You need to try without standardization and you should tell me for this particular data set whether it is giving a good score with the standardization or without standardization. And then I have also, I have actually imported all the libraries and packages now. Let us now load the data set. So you can give any name here just because it is, okay. So let me run this code first. Okay. So now I have named it like a BC data. Whatever name you want to give here, you can give it, right? Just because it is breast cancer data set, I have written BC data. So let me check the shape of the data. There are 569 rows and 32 columns in my data set. Dot D types, if you see, you can see that everything is been a number here, right? So ID is integer. As we have discussed in the Titanic data set, definitely ID is not helpful to us. So we can remove this ID column. Other than that, diagnosis, you can see, diagnosis is basically object, which is basically categorical. And this is the dependent variable here. So in the Titanic dataset, if you see, in the dependent variable, we had like a 0 and 1. 0, I said, though it is represented as number, 0 is independent variable, sorry, 0 is not survived and 1 is survived. But here diagnosis is actually object, which is the dependent variable. So it is directly giving me an idea that it is basically the classification model, right? So what I am just doing now, I just have this diagnosis column. I want to take it as a category column only, and then let me get the descriptive statistics of my data, right? So I have written dot transpose. If I do not take transpose, what will happen now? You can see that for all the columns, I need to drag it like this, right? So instead of that, what I can do, I can write like a dot T or dot transpose dot T I can write. you can see that easily we can look into all the statistic part, right? So this is working fine. So when you write parenthesis here, what will see? See, let me tell you the error. Whenever you say that not callable, which means that you need to actually delete the parenthesis, right? So this is working fine. So now I want to know whether my data set is balanced or not. How to find out whether it is balanced or not? I want to know how many benign, how many malignant are there. So now if you see this one, there are 357 benign and 212 malignant. Yes, there is a difference between the two classes, but it is fine to go ahead without balancing the data set. So it is perfectly fine. So we are proceeding with this. Now, as I told you, ID column is not required, right? So you can directly also write like a BC data dot drop. And what is the name of the column I'm going to drop now? That is basically ID, right? So let me see whether it is working or not, right? So I'm writing ID. You can see that now this might have been dropped. Let me check the shape. Now before that we had like 32 columns. Now we have only 31 columns. Okay. Just because there are no issues with the data set, no missing values. Let us check first. df dot is null dot sum, right? So when I do that, you can see that whether there is, okay. So data frame is here BC data, right? So BC data, you can see that there are no missing values in our data set. Okay. So in y-axis, what I should take? The dependent variable. What is the problem statement here? To predict whether the person has malignant cancer or benign cancer, right? So diagnosis is the column, which is the dependent variable here. So I'm taking that in the y-axis. In the x-axis column, what I'm doing, data frame dot drop. You can write like directly, no need to write labels. You can directly write diagnosis, comma, axis equal to 1, right? So when you see that now, it's perfect, right? If you see X, diagnosis is actually removed. In case if you want to try with Y, you can see that you will be actually able to see, okay, because this is small y, you can see that this is how the data set is looking like. Okay, so in case if I want to check with the 25 observations, you can see that malignant everything over here, right? So you can also check with that. So once you assign data for X and Y, what is the next step? I'm going to do the standardization. Okay, so once you reach this stage, right? Everyone, please listen. Once you reach this stage, pause the video, then split the data into train and test. Split the data into train data and test data. And then already we have learned logistic regression. So try to apply logistic regression on this data set and get the score, right? Try to get the score, right? So then what you need to do? You need to apply KNN model, right? So how to apply KNN model? Just I will guide you on that. But I'm going to do the standardization now. So what I'm doing, only the X attributes I'm taking, I'm applying Z-score on that, right? So what is Z-score? All that part we have discussed in outliers from scratch, all those videos you could have seen. And there is another video, standardization and normalization. So please look into that video to get more clarity on standardization and normalization, right? So once I do that, before this, if you see how the data was looking like, we had like a this way, right? I mean, like a radius mean, if you take a 1.412729 E01, right? So now this is actually changing. That can you see minus 16, all that. So basically, when each attribute has different units, we want to standardize that, right? So in short, if I say we need to standardize it, that's the reason I have applied Z-score now. So once I applied a Z-score, what I want to do, I want to split the data into train and test. So I have taken it like 70 and 30 ratio only. Okay, 70 and 30 ratio. As usual, X train, X test, Y train, Y test, which is equal to train underscore test underscore split. When you pass it now, you pass first X. Don't write X scaled, okay? Just you pass X, then Y, then test size equal to 0.30, random underscore state is equal to 1, right? Then I want to instantiate it, the algorithm, right? So here I have written like N and H. You can write like a model 2. Why I am asking you to write model 2? Because already you might have written model 1 for logistic regression, right? If you have done logistic regression part, you can write like a model underscore 1 is equal to logistic regression. If you are directly writing this only, you can write this, right? K, capital K, neighbors, capital N, classifier, capital C. Then I'm writing like N underscore neighbors. I'm trying with the 5 neighbors, and then weights I'm taking it like a distance. Okay. So the first one, you can also remove everything. Just keep the parentheses and run the code. Then also you can change it. Right. So once I do that, I need to fit with the train data. So model underscore 2 dot fit X underscore train comma Y underscore train. So I have fitted with the train data. Then I want to predict it with the test data, right? Why I'm doing the prediction part? Because I want to run the confusion metrics. So I am doing this. Okay. So this is basically again model underscore 2. You can see that the score is 96% for test data. So we are not supposed to stop here. Let us also try with the train data now. So 2 dot score X underscore train, comma, Y underscore train. Right? So let me run it. You can see that 1, which means 100% with the train data and 96% with the test data. So the difference is lesser than or equal to 5%. So I can say that it is not an overfitting model and it is basically a generalized model, right? So once I do that, I can go ahead with the confusion matrix. Now listen, what is the task I asked you to do? You write this step like X, Y, then write this one, right? X underscore train, X test, Y train, Y test, right? Train test split, right? X, Y test size, random state. Here, instead of K neighbor classifier, try with logistic regression. That should be model 1. In model 2, what you are supposed to do, write X and Y. Okay, already you might have written that. So no need to rewrite it. Just you directly write model underscore 3 equal to K neighbors classifier. Continue from this for the second algorithm. The third one, what you need to do, now you need to start with X scaled equal to X dot apply Z score, and then you do this, then pass X scaled, then do the model 3 with the scaling. So finally, you need to tell me 3 scores. What are the 3 scores? Model 1, do logistic regression, find out the score. Model 2, do KNN without scaling. Then model 3, do KNN with standardization, Z score I said, right? So try with all these 3. What all we can change, right? What all hyperparameters you can change is once you make this model, right? Then you try to change these numbers like N underscore neighbors. As we have discussed, the number of neighbors should be an odd number only. You can try with 3, 5, 7, 9 with all the numbers. And also, you can also change the hyperparameters like weights. By default, it is uniform, but I have taken like a distance. You can also try with a metric, okay? So metric is equal to Witkowski is default. So if you want to change that to other metric also, we can actually do that. So instead of changing the metric, what you can do, you can see that p value is 2, right? You can also try with the p is equal to 1, right? So what all combinations you need to come up with? N underscore neighbors, weights, and also p, right? Try with this and get the best score. Okay. So let us now see the confusion matrix. From sklearn import matrix, I want to print the confusion matrix with actual y and predicted y. In logistic regression, we have written labels 1 and 0 because that is survived, not survived. Here there are two labels like a malignant and a benign. So I'm writing like a M and B. And then the same loop, wherever we have written 0 and 1, that is being changed to M and B. Predict 0, predict 1 was there. So we are changing it to predict M and predict B, right? So if I run this, let me see whether it is working or not. Yes, it is working fine. So let's see. This one, if you see, this is true cases, correct? Why true case? Predict M, M. So predict B, okay, you can see that the scientific notation, right? So 1.1 is 02. So what we have to do, if you remember, in the last algorithm, I told you FMT, right, equal to G. So now you can see that 112, right? So this is true, this is true. Just because our score is really good, because we are getting the confusion matrix for test values only, 96 percentage, right? So we get only very less score, right? I mean, a very less misclassified data. 4 and 2, false positive and false negatives are just these two numbers, right? Totally false cases are 6, correct? So I hope this is clear to everyone. Try with all these and get these scores. If you have any questions, you can put it in the comment. I will just try to clarify your doubts. Okay. So thank you all. See you in the next video.